At 828 meters above Dubai, a worker clips into a cable. A heavy maintenance door opens into the open air. He steps through the gap and is suddenly suspended above the city. The wind immediately catches the ropes. The sound of breathing mixes with the metallic click of safety connectors. There is no solid ground for nearly a kilometer straight down. This looks like a story about window cleaning, but that is a profound misunderstanding of what is actually happening here. The visual perfection of the Burj Khalifa is not a passive feature of its architecture. It is a continuously manufactured illusion, an illusion maintained by custom machinery, rigorous inspection, and permanent economic obligation. The true cost of a flawless glass facade is not found on a monthly cleaning invoice. It is found in the extreme logistical operation required to stop the world's tallest building from visibly aging. The physical reality of the tower begins with a single pane of glass. Water moves across the surface. A squeegee clears the dust. But that single pane is just one fraction of an enormous mathematical problem. The exterior cladding of the Burj Khalifa is built from close to 26,000 individual glass panels. Cleaning this entire exterior is not a task that can be finished in a weekend. A complete rotation typically requires 3 to 4 months of continuous vertical labor. This creates an unavoidable maintenance loop. By the time a crew reaches the final lower sections, the upper levels have already been exposed to months of desert dust. The building never remains permanently clean. It is simply a massive surface moving through an endless cycle of intervention. The logical assumption is that a modern skyscraper should have a simple automated solution. You might imagine placing one massive crane on the roof and dropping a conventional cradle straight down to the ground. But the Burj Khalifa is not a flat vertical wall. It is an upright maze. The tower features 3 distinct wings. The geometry tapers and steps back at multiple elevations. There are deep recesses and complex angles that a single roof-suspended cable could never reach. A conventional machine, descending from the peak, would simply swing uselessly in the wind, far away from the glass. The tower cannot touch its own skin without mechanical arms hidden inside its body. The solution to this geometric puzzle was to build an access infrastructure directly into the structure. Engineers from CoxGomyl designed 18 customized building maintenance units for full facade access. These are not standard window washing baskets. They are highly specialized machines distributed across different mechanical zones, hidden throughout the tower. When a cleaning cycle begins, specific wall panels retract. Heavy mechanical tracks deploy outward. A large structural jib unfolds over the edge of the building. Only then does the cradle descend to meet the glass. This allows the crews to access the complicated setbacks without relying on a single impossible drop from the roof. But even 18 custom machines cannot easily reach every corner of a tapering spire. Above the main maintenance zones, the architecture stops behaving like a building and begins behaving like a mast. The physical space for large deployment tracks disappears. The upper structure becomes incredibly narrow against the extreme wind. At these extreme upper elevations, conventional cradles are often no longer practical. This is where industrial rope access capability becomes the only viable method. Trained technicians must suspend themselves directly against the highest structural elements. The tower forces human workers into the open, where machines can no longer fit. Look closely at the preparation required for a single suspended shift. This is not reckless thrill-seeking. It is a highly regulated industrial procedure requiring trained and certified personnel. Organizations like IRADA International require technicians to undergo rigorous training and recertify every 3 years. The preparation is methodical. A primary harness connection is locked into place. A redundant backup connection is secured independently. Radio communication systems are tested. Equipment is tethered to prevent anything from falling into the city below. Every carabiner and tension line is inspected before a single boot leaves the floor. And yet, no amount of certification removes the physical vulnerability of the moment. Would you step through that opening even after checking every safety line? Once outside, the sensory reality of the environment takes over. The metal of the cradle absorbs the ambient heat. That heat can be felt pressing through heavy protective gloves. The tensioned ropes vibrate slightly in the moving air. Water applied to the glass does not always fall straight down. It is often pushed sideways by unpredictable microcurrents moving across the facade. The noise of the city is entirely stripped away by the extreme altitude. A worker adjusts his balance as the skyline slowly shifts behind his reflection in the angled glass. Everything is precarious, and at this height, gravity is not the only physical force threatening the operation. Wind is the primary antagonist of vertical maintenance. It does not just threaten physical control, it threatens the schedule. The atmospheric conditions 500 meters in the air are vastly different from the conditions at street level. A perfectly calm morning on the ground might mask a dangerous crosswind near the spire. The invisible force of the wind directly affects the stability of a suspended cradle. It dictates the trajectory of water and cleaning solutions. If the wind speed exceeds strict safety thresholds, operations must halt immediately. A crew can be fully prepared at dawn. The internal machinery can be deployed. The harnesses can be checked. But the building can still refuse to let them work. This creates a profound economic inefficiency. The workers are present. The supervisors are managing the site. The highly engineered building maintenance units are powered on. But no progress is made. A 3-month cleaning cycle is not built from continuous perfect days. It is assembled from narrow windows of usable weather. Every delay extends the duration of the cycle. Every hour spent waiting for the wind to drop is an hour of accumulated expense. Cost continues to build, even when no pane is being cleaned. This forces a fundamental question about how we calculate the price of maintaining this structure. Should the price of cleaning one pane be measured by the person holding the squeegee, or should it be measured by the entire system required to place that person there? If you look at the cost layers visually, a different picture emerges. Trained labor is only the surface layer. Beneath that is the cost of operating custom machinery. Then, there is the expense of mandatory safety systems and rescue readiness. There is the financial drain of weather delays. And most importantly, there is the infrastructure required for inspection and glass replacement. The 18 customized building maintenance units were not designed exclusively to wash away dust. They are a permanent engineering capability installed to service the skin of the building. When one pane can no longer simply be cleaned, a routine task escalates into a suspended engineering operation. This reveals the true nature of the mechanical storage spaces hidden behind the facade. A portion of the tower internal volume exists primarily so the building can reach its own exterior. These hidden rooms house heavy winches and thick steel cables. They contain complex control systems and heavy-duty motors. There are heavy rails designed to guide the massive structural jibs outward. Every component of this access infrastructure requires its own rigorous maintenance schedule. The building maintenance units themselves must be inspected and certified for heavy lifting. The cables must be checked for wear and tension fatigue. The tower has essentially built an industrial facility inside a luxury property. Without these mechanical arms, the building would be completely helpless to repair itself. If a motor fails or a track jams, the facade in that zone becomes inaccessible. The infrastructure used to maintain the building creates its own secondary maintenance burden. It is a heavy and permanent presence. It must operate flawlessly under relentless environmental pressure. The environment attacks the schedule with more than just wind. Sunlight behaves like a physical barrier moving across the three wings of the tower. Extreme desert heat changes the fundamental properties of the working surface. Different facades receive intense direct solar exposure at different times of the day. When the sun hits the double-layer glass, the surface temperature rises dramatically. Hot glass drastically alters working conditions for the suspended technicians. Water applied to a heated surface evaporates almost instantly. Cleaning solutions can dry too quickly and leave stubborn streaks across the polished finish. To avoid this, operations must constantly chase the shadows. Crews must carefully time their drops to align with the shaded sides of the structure. This requires intense logistical coordination. A facade that is perfectly shaded at 8 in the morning might be blindingly hot by noon. The rotation of the Earth dictates the daily operational schedule. The desert does not need a dramatic storm to disrupt the process. It increases the overall cost of maintenance simply by making every ordinary task narrower and more conditional. The crews are always racing against the moving sun. If a team falls behind schedule due to morning winds, they might lose their shaded working window entirely. They are forced to wait for the next optimal alignment. This intricate dance with the environment stretches the timeline further and further. This constant physical access provides something much more valuable than a washed surface. The general public believes this operation is entirely about removing dirt, but that assumption ignores the forensic value of proximity. Physical access creates a rare opportunity to observe the exterior condition of the tower up close. Cleaning removes what is visible to everyone. Inspection searches for what should not be there. As technicians move systematically down the facade, they are positioned to notice subtle changes in the materials. They can observe the condition of the heavy sealant securing the panels. They can check the rubber gaskets, designed to keep out moisture and extreme heat. They can inspect the intricate aluminum framing that holds the double-layer glass in place. A trained eye might spot a compromised joint before it becomes a structural vulnerability. They might document a deep scratch or identify early indicators of water entry. Any loose components or surface damage can be recorded and passed to specialist engineering teams for review. Regular visual contact is the first line of defense against long-term degradation. If the access system were to fail, dirt would be the least significant problem. Delayed access means delayed detection. A minor sealant issue that could be resolved quickly might escalate into a complex moisture problem inside the facade. The building relies on these routine cleaning cycles to diagnose the health of its outer skin. But what exactly happens when the problem identified is not just accumulated dust? What happens when a panel requires major repair or complete replacement? This question leads directly into the opaque economics of vertical maintenance. There is no verified public invoice that reveals the exact annual cost of cleaning the entire Burj Khalifa. The precise financial figures remain heavily guarded commercial information. However, chasing a single annual number might be the wrong way to understand the economic burden. The true expense is not one cleaning contract. It is the permanent obligation to keep an entire maintenance ecosystem alive. Consider the layered reality of the total cost structure. The foundational layer involves the daily wages of trained labor and the cost of consumable materials. The second layer adds the ongoing expense of safety certifications and emergency rescue readiness. The third layer is the permanent mechanical maintenance required to keep the building maintenance units operational. The fourth layer absorbs the continuous financial losses caused by weather delays and unusable working windows. The fifth layer funds the specialized capability for facade inspection and emergency repair. And the final layer represents the invisible cost of neglect. If any part of this system is underfunded, the consequences multiply rapidly. A premium facade is an essential part of the presentation for a luxury asset. Presentation directly affects reputation and brand value in a highly competitive global market. Delayed maintenance makes future repairs exponentially more difficult and disruptive to the tenants inside. The permanent financial commitment is massive, even if the exact number is never published. It is a financial stack designed to prevent the building from losing its status. But a polished reputation is put to the ultimate test when the glass itself fails. At ground level, a broken window is a simple repair. At 800 meters in the air, a damaged panel becomes a suspended logistics operation. Imagine a scenario where a technician wipes a section of glass and a severe mark remains. The worker pauses and examines the surface closely. A deep structural flaw or a shattered outer pane is identified. A radio call is made to the engineering control room. The operation immediately shifts from routine washing to heavy material lifting. This is why the permanent facade access system was built with immense capacity. According to the access system documentation, the equipment includes approximately 600 kilograms of material hoist capability. The official architectural sources describe individual glass panels weighing approximately 362 kilograms. While not every panel is identical in size or weight, moving any piece of the facade is a formidable engineering challenge. Engineers must pinpoint the exact location and specify the correct replacement unit. They must establish strict weather limits for handling a heavy flat pane that acts like a sail in the wind. The ground zone directly below the operation must be heavily secured to eliminate any risk to the public. Specialized lifting equipment is prepared inside the mechanical levels. The heavy replacement panel is moved carefully into position. A suspended load of this size must be stabilized perfectly against unpredictable wind currents. The technicians must then remove the damaged component while suspended in their harnesses. Every bolt and seal must be extracted without dropping a single piece of debris. The new panel is slowly guided into the empty space. It is mechanically secured and heavily sealed to restore the weatherproofing of the structure. Finally, the completed work undergoes rigorous inspection to ensure absolute structural integrity. The tension in this process does not come from loud, dramatic action. It comes from the terrifying demand for absolute precision in an inherently unstable environment. A heavy glass panel suspended above a crowded city leaves zero margin for human or mechanical error. Why does the building appearance carry such immense economic value beyond simple cleanliness? The answer requires understanding what the Burj Khalifa actually sells. It functions as a luxury residential address and an exclusive corporate location. It operates as a premium hotel and a high-revenue visitor attraction. But primarily, it serves as a global visual symbol representing the ambition and capability of Dubai. A visibly maintained exterior directly supports the premium image the tower is expected to project. In my view, the Burj Khalifa is not cleaned simply because glass naturally gathers dust from the desert. It is cleaned because visual perfection is one of the core products the building delivers to its occupants and investors. If the glass were allowed to become severely stained, the perception of luxury would immediately begin to degrade. The prestige of the address is inextricably linked to the flawless reflection of the sky on its facade. Long-term access capability is what preserves the exterior condition of this massive architectural asset. But this leads to a deeply uncomfortable philosophical question. If a symbol can appear timeless only through constant, expensive, and intensive human intervention, is it truly timeless? or is it merely being forcefully prevented from showing its natural age? The architecture is fixed in place, but its pristine condition is a daily performance. The tower requires a permanent army of workers and machines just to maintain the illusion of effortless permanence. This dynamic is not entirely unique to this specific tower. It represents the extreme limit of a much broader skyscraper maintenance problem. A building longevity is not determined solely by whether its massive steel and concrete structure remains standing. It is equally determined by whether human beings can continue to access its outermost layers. As modern glass towers become taller and geometrically more complex, their surfaces become increasingly hostile to maintenance. Can crews safely reach the upper elevations to inspect the seals? Can the internal machinery continue to operate after decades of heavy use? Can the property owners afford the escalating costs of specialized rope technicians and replacement components? The taller and more geometrically complex a building becomes, the more maintenance must be designed into it before construction even begins. If a structure cannot be reached, it cannot be cleaned. If it cannot be cleaned, it cannot be inspected. And if it cannot be inspected, it will eventually begin to fail. The global trend toward wildly asymmetric architecture often prioritizes visual impact over practical accessibility. But gravity, wind, and material degradation never stop acting on a facade. The Burj Khalifa simply amplifies these universal challenges to a scale never before attempted in human history. It proves that the battle against the elements requires much more than strong foundations. Return to the worker suspended against the glass. He carefully removes the last stubborn streak of water from the heated glass pane. He adjusts his harness and shifts his position to begin the next panel. From the ground, the Burj Khalifa appears effortless and unyielding against the desert sky. Up close, that monumental appearance is completely fractured. It is divided into tens of thousands of panels and months of repeated physical work. It relies on hidden mechanical tracks, human training, and narrow weather windows. It demands constant inspection, heavy repair capability, and a permanent financial commitment. The cycle offers no final victory. The machinery will retract, the crews will descend, and the dust will immediately begin to settle once again. The tower is 828 meters tall. So is the obligation to preserve it. And tomorrow, another pane will already be dirty. This video is produced for educational and documentary purposes to explore the engineering and logistical maintenance of extreme architecture. Information regarding access systems, weather impacts, and general maintenance procedures is based on official architectural specifications and industry standards for facade management. This analysis does not represent the exact real-time operational status, current financial records, or specific contractor schedules of the Burj Khalifa. This content is not intended to replace professional structural engineering or architectural consultation. If you found this investigation into the hidden cost of architectural perfection valuable, please consider subscribing to the channel. What is your perspective on building structures that require permanent mechanical intervention to survive? Share your thoughts in the comments below, and join us in the next video as we continue to uncover the hidden systems that keep modern cities alive.